Okay, I'm still in this serverless topic, and I want to move on to this set of slides here. I essentially want to cover two more services, one called the API Gateway, and the other one is called Cognito. And that's about it then, really. We'll hand over to Frank then to start looking at the front end, probably next week, maybe. We'll see how far we get today anyway. So it's this set of slides that I want to walk through with you. And there's actually two labs that you need to work on for this week. Definitely this one here. And depending how far we get, you can also work on this one here. So let's bring up this set of slides. Now, this is an image I would have shown you probably on week one, maybe, or maybe week two. And it's kind of a visual representation of what we mean by a web API. I'm sure people would have known anyway prior to this module. And so what we can now say, if we're developing this web API using a serverless platform and in particular AWS's offerings in that space, then the functionality here is going to be implemented by Lambdas. Now, what we need to look at though is how do we satisfy this part here? How do we give these lambdas an interface to the outside world? The outside world being all of these clients on the left-hand side. Now, admittedly, we did see when we looked at Lambda, we had the ability to get the Lambda service to generate a unique URL for each Lambda function. And then that's one way of making a Lambda accessible by a client. But I guess the problem with that is that each Lambda's URL is completely independent of every other Lambda's URL. And perhaps the set of Lambdas that you have here are kind of collectively, they represent an overall application. So it's clearly more desirable to have one sort of entry point to the collection of Lambdas that you might have here. And that entry point is what we call a web API. And the service that we use on the AWS platform to achieve that is a service called API Gateway. So we'll just look at the basics of this really. There's lots of configuration options available on it, but we'll just cover the basics for now anyway. Another way of kind of representing API Gateway within the suite of services, serverless services that AWS offers is shown on this slide here. And API Gateway kind of comes under the heading of communications related service. And that makes sense, I guess, in that it allows not just external clients to communicate with your internal logic, but you could have internal clients as well communicating with internal logic via a gateway. So that's why I'm kind of representing it down here. Now, there's all of these other services as well in the communications space. An EV that studied the cloud architecture module last semester would recognize some of them, but unfortunately, we're not going to get to cover any of these in this module. Okay, so what it is then, what API Gateway is, we kind of already have an indication of based on what I've said so far, but the kind of the definition, if you like, of what the API Gateway service is that again it's fully managed, which is as we know now a byword for serverless. There is a server there running on your behalf, providing the API service, but you don't have to worry about maintaining it or getting it, rebooting it if it goes down. All of that is taken care of by AWS. So it's a fully managed service, and you can use it for creating web APIs, for maintaining them, for monitoring them. Monitoring being seeing how much traffic is hitting your web API. We won't be looking at that though. Uh, Obviously, you'd like to build some security aspects to your web API. Maybe you only want authorized users to access the backend functionality that lies behind your web API. And as we know now, a web API, there are kind of the recommended design, I suppose you could call it, of web APIs is to follow this RESTful approach, which I'm not going to cover REST now as a design style. I'm assuming people have come across REST before. HTTP is a kind of a lightweight form of REST, if you like. So that's why we're seeing either creating REST APIs or HTTP APIs. Although in a way, maybe this is a distinction that the API gateway service makes. It does have two offerings in the web API space. It has REST APIs and what it calls HTTP APIs. And really, you could think of HTTP APIs as a more lightweight um, form of REST, if you like. Yeah. It does also support the WebSocket protocol for two-way communication between your backend and your client. We won't get a chance to look at that though. Okay, so it covers the full spectrum, if you like. And in the image then below, I'm showing you sort of your classic three-tier serverless in brackets, really, but it's a three-tier web API architecture. So we now know that we're going to be using this gateway service to provide this part of our three tiers. We've looked at Lambdas already, and we've looked at DynamoDB. So this is the final piece of the jigsaw, if you like. And essentially all the gateway does is it takes the requests, the HTTP requests that comes in, and it proxies them onto the relevant Lambda. Again, the assumption is that there are a number of Lambdas now here, and depending on essentially the path name of the that's included in the request, the path name is used by API Gateway to determine whether it should invoke this Lambda or this Lambda or this Lambda or whatever. Um, So, so we use API Gateway to create, let's just restrict it to RESTful web APIs. Now, there's lots of configuration options though within that we can avail of, the majority of which we won't be looking at, but I'm just listing them here anyway. So API Gateway supports the versioning of your web APIs. This would be quite a common practice in industry, in that you would have a more than one version of your web API available to your clients, simply because maybe some clients may have been using your web API from quite a while back, so they would be tied to an old version of your web API, and they don't have the time or effort to upgrade their clients so that it talks to the newer version of your web API. And therefore, we need to be able to allow clients to access more than one version of our web API. So the API Gateway supports that. Secondly, I'm saying there it handles different environments, and by environments now we kind of mean dev, test, prod. You can have other environments too, and they don't have to be called dev, test, and prod. They're just kind of conventions, but that's what we mean by environments as opposed to versions up here. Handles authentication and authorization, which you would expect and we will look at that in a fair amount of detail. You can get it to generate API keys. The idea being that you would then provide an API key to your users, and that would be the means of authentication. We won't be using API keys though. We'll use your more kind of traditional um, username password set of credentials. Swagger is a technique for designing web APIs. Again, you may have heard of Swagger. With Swagger, what you do is you create kind of templates showing the design of your web APIs, and then you give those templates. In this case, you give them to API Gateway, and it would use the Swagger template to generate the necessary AWS resources to set up and create your web API. OpenAPI is an alternative to Swagger. Supports, I've already mentioned that for WebSockets. Quite often, the requests need to be transformed. The request generated by the client needs to go through some sort of transformation before it can be passed on to the backend. You can describe the transformation using some form of templating um, tooling, and the API gateway will do the transformation for you. Equally, you may want to have validation of certainly if there are payloads included with a request from a client, as in a post request, then you can do the validate. You can get API gateway to perform the validation, or you can let the Lambda that's receiving the request ultimately to do the validation. But API gateway can be configured to do that. That's actually going to be relevant to the assignment that I'll be giving you, which I'll talk about next week. Um, what you can also get the gateway to do is to generate an SDK for your web API. I mean, your web API is essentially a HTTP accessible interface. Now, rather than having to program raw HTTP requests in your clients, you could actually get API Gateway to generate an SDK for your web API. And then your clients are just using that SDK to communicate with your web API. Uh, okay, and DDoS is also supported. So these are essentially most of the configuration options that are available to you when you're creating a web API. And we need to see how you do that in the CDK side of things. But that's kind of the big picture, if you like. Now, so here's Gateway, right? And uh, I'm calling this over here the backend. Now, it turns out that the backend isn't just restricted to lambdas. The backend could be other types of resources as well. For example, here I'm showing you that the backend is an SQS Okay. So the integration between your API gateway and your backend, you have to declare what type of integration do you want between the two. And that's, in a way, that's dictated by the nature of your backend. Okay. There are four options, I think, available to us. And I'm just listing them on this slide and the next slide. We'll only be focused on one of them because in all cases, our backend is just going to be a Lambda. But just keep in mind that it can be other types of resources other than Lambdas. Um, Presumably, when you're kind of creating your web API and you're just setting it up or creating it, and you want to do some primitive testing or preliminary testing of your web API, and maybe the back end isn't ready yet, it hasn't been developed yet, or you don't want to integrate them fully yet. You just want to do, as I said, some preliminary testing of your web API. In that case, what you would say in your CDK code is you would use the mock integration type, and as its name kind of suggests, that way then you can send requests to your web API, but the web API will just generate a standard response. It won't proxy that request onto any backend at all. So that's kind of a default integration type for a web API. Here's a more realistic example, and it kind of relates to the image that we're showing. Now, unfortunately, when you read up on API Gateway, it has different names for these integration types. And I'm trying to cover all of the names here, but you may come across a name for the integration type that's slightly different from what I'm giving you here. But it'll be fairly obvious which of the integration types it is. So anyway, there's an integration type which some documentation refers to as the AWS services integration type for your web API. It's also referred to as HTTP/AWS, but let's use this one here. Now, that integration type is typically used when the backend is something other than a Lambda. Okay. And let's take this specific example here where it's an SQS queue. Now that means there's a request coming in, a HTTP standard HTTP request coming in here. Maybe there's query string part to it. Maybe there are path parameters. Maybe there's a payload. There's going to be HTTP request headers that may contain useful information that needs to be available at the backend to the backend. But how do we transform this HTTP request into a form that is suitable for your backend? And that transformation has to be done by API Gateway. And uh, there are mapping templates that you have to write up, type up, and attach to your web API. And these mapping templates describe how a request, a HTTP request, is transformed into a form that is suitable for your backend. Yeah. And similarly, if there is a response from the backend, there typically wouldn't be with SQS, but if there is a response from the backend, that response equally has to be transformed into a form that is suitable for transmission across your HTTP connection. So that's another role really that the API Gateway will carry out on behalf of your web API, provided you provide these mapping templates for it. The third type of integration, and this is the one that we're interested in, is well, many articles that you read about it calls it the Lambda proxy. It's also called AWS proxy, I think, in some places. And with that integration type, the backend is assumed to be a Lambda, as is shown on the image. And there isn't really any need for transformations, mapping templates in this scenario, which I'm saying here, right? So API Gateway essentially API Gateway knows how to talk to a Lambda. It doesn't need some assistance from your mapping templates to do that. So it will take your HTTP request. It will actually do some transformation on it, but it knows how to do that transformation. And this is important actually, as we'll see a little bit later on, but just to give you the heads up on it. So you've got your HTTP request, and as I said, that request may include a query string, It will include request HTTP request headers, and all of that needs to be available to your Lambda, potentially because it may need to know about it. And so what the API gateway does is it essentially packages all of that information into the event object that is available to your Lambda. We know that the first argument of our Lambda function is this event object. Well, the API gateway will put all of the relevant information associated with the request into that event object. And we'll see that in a little bit when I do some demos with you. So anyway, the integration type here, as I said, is called Lambda proxy or AWS proxy. There's also an integration type called HTTP proxy. And with HTTP proxy, it takes the HTTP request that comes in from the client and it essentially forwards that exact same HTTP request. So this is assumed to be a HTTP protocol uh, connection that's going on here. So it just proxies the HTTP request onto the backend. For example, if your backend is in application load balancer, and that's something that you would have seen quite a lot of, um, maybe not so much currently, but certainly historically. And as we know, an application load balancer understands, if you like, the HTTP protocol. So in that case, your gateway doesn't really need to do any work at all. But we'd still like to have a gateway here because maybe we want to do some validation here, or we want to perform some authentication here. Okay, so rather than taking the API gateway out of the uh, loop completely, it still may be useful to have it as part of your architecture or your infrastructure, sorry. So anyway, if you do want to, uh, if your backend, sorry, is something like an application load balancer and you still want to have an API gateway in front of it, then the integration type that you use for this connection is the HTTP proxy integration type. Right, so that's what is it? 4, sorry, four integration types that are available to us, and you pick the one that's relevant based on the nature of your backend. Always, if you have HTTP as a if you've got HTTP, sorry, on kind of on the server side, uh, then you need to be conscious of CORS, and I'm assuming people are familiar with CORS. So you always have to configure CORS for your web API via the API Gateway service. And just a quick reminder, what's CORS all about? Um, so your API, your web API is going to have a domain name associated with it. Now, you can actually customize the domain name, but if you don't want to do that, then there is a domain name generated by the API gateway service itself for your web API. So either way, it has a domain name. Now, if your client or clients that want to talk to your web API, if they are associated with a different domain name, then in that scenario, you have to configure CORS for your web API. And essentially what the CORS configuration is indicating, hopefully as you know already, it's indicating what domains does your web API accept requests from. Yeah. So in the image, I'm just giving you a typical kind of scenario. Let's suppose we've got a React client. This is the React logo and it has a domain name, which is different from the domain name of your web API. And so uh, we need to configure CORS for our web API, indicating whether it accepts requests from this domain name or not. I'm also just for the sake of completeness, this image here is representing an S3 bucket. Again, S3 is a service that those of you that studied the cloud architecture module in the previous semester would be familiar with. But you can configure an S3 bucket to be the host for your web app, e.g. your React app. We might get an opportunity to do that at the very end of this module. But either way, the general point from a course perspective is that this web app has a different domain name from the domain name associated with your web API on the right. And so the way the HTTP protocol works in that scenario is it first of all sends a pre-flight request. Where's my pre? Here. It sends a pre-flight request essentially from the client to the web API, asking it, what domains do you accept requests from? And the response that's coming back here from the pre-flight request is stating what domains it accepts requests from and what methods. And provided that the client is included in the list of domains that it accepts requests from, then the client will actually send the request that it wanted to send in the first place to the web API. That's just basic cores, and I'm sure everybody is familiar with cores already. So the only thing we're really interested in highlighting here is that we do need to configure cores for a web API that is created using the API Gateway service. Right, simple demo time. Supposing I want to, and it's kind of your classic 101 example, but I want to have a web API that is the front end that is providing an interface to a backend that's managing to-dos. Surprise, surprise. And let's supposing I've designed my web API such that it provides these two paths or endpoints. So there is a slash to-dos endpoint, which supports a get and post request. The get request, I want a get request to this path to return all of the to-dos currently in my database. A post request will be issued to my web API when the user wants to add a new to-do to the database. This path here, slash to-dos slash followed by a path parameter, where the path parameter in my case represents the ID of a to-do. Yeah. And this path name or endpoint, let's use the REST terminology, this endpoint only supports GET requests. And the idea is that the client or user is looking for details on a specific to-do. So there are two endpoints. This one supports GET and POST. This supports GET. And I've explained what the responses to these requests should be. So I want to create a web API that represents this particular specification, if you like. Now, we're not really interested in the lambdas, okay? They're kind of trivial, so we're not going to focus on those at all. In fact, I just have a kind of a dummy lambda that just does a console log of the event that's passed to it, and it doesn't do anything else, doesn't talk to any database. So there's no real functionality behind the scenes. But I did want to have a lambda there just to show you one or two things. I didn't want to use the mock integration. So I do actually have a lambda behind these. And it's one lambda is dealing with everything, which may not typically be what you would have. What's next? Okay, if I look at this slide here. So this is the CDK code for creating a web API. Yeah. And so if we take it from the top, am I looking at the right one now? Sorry. Yeah. Okay. all I've got here is just I'm creating a Lambda instance. So this is the Lambda that's going to be the backend for my entire web API. Okay. And here's the web API stuff. So surprise, surprise, there's a CDK L2 construct called REST API, and that does what you think it does. It creates the actual shell, if you like, creates a shell web API for us. And I've got some configuration settings for it. This is the core settings that I was talking about. So my core setting is pretty much open-ended. I'm accepting requests, or the web API is accepting requests from every other domain, and it accepts all of these methods. Yeah, so it's pretty fully accessible. The dev here is, even though it's using stage name here, that's what I was referring to as environments at the beginning there. So this is for the dev environment. Although you can put any kind of string there that you want to, but this will actually, dev will be part of the URL for this web API. That's how we kind of recognize it. So that's fine. That's just creating, as I'm referring to, as a shell web API. Now we've got to build up the different path names that I want my web API to support. And that's what's going on here. So we want to add a resource. Resource is kind of the same idea as an endpoint. We want to add a resource to the root of our web API. And in this case, the resource is the path name is a static string. So just to-dos. So that to-dos there, if I go back, corresponds to this here. Yeah. Then so that creates a resource or an endpoint for me. And then I'm indicating here what methods I want that endpoint to accept requests for. So here it looks like I'm accepting GET requests to this particular endpoint. And this is how we integrate the backend with our web API. So Lambda integration is another L2 construct. And as its name suggests, this is the integration type between a web API and a Lambda backend. So it's that Lambda proxy integration type that I was talking about earlier on. And this constructor you need to refer it to a Lambda function. So this is referring to my Lambda function up here. And proxy true, that's okay. That's just kind of a default. So that's fine. I'm also adding the post method to the same endpoint. And again, it's a Lambda integration. And as you can see, I'm using the same Lambda function, but I've already explained why I'm doing that, because my Lambda isn't really doing anything significant. So that's my get and post. So all of that code there is dealing with this here. So now I need to deal with this part of my web API's design. And I essentially want to add a new endpoint or resource, tag it on to this one if you like. That's the way you think about it. Each of these, between the slashes, each part is a new endpoint or a new resource. So if we go back to my code, here I'm adding a resource, but in this case, I'm not adding the resource to the root, which I was up here. Now I'm adding the resource onto the existing resource, which is this one here. And in this case, in this case, the the path is not a static path, it's now a parameter. So the curly braces here indicates that this is a path parameter. part of the URL associated with this endpoint. Doesn't matter what you call the path parameter name here. I guess it would make sense to give it a meaningful name, but it's completely arbitrary. So I've called it to-do ID, which makes sense. And again, I'm adding some methods to this second endpoint, which I've called the to-do details endpoint. And it only supports a get in this case. And again, it's a Lambda integration because it's a Lambda backend. Okay, what's next? No, I don't want to do that. So if I just switch over to VS Code, and here's the project, here's the stack file, which I have been looking at. If we just take it from the top again, okay, here's my Lambda function, nothing interesting there. And the rest then is what I was showing you on the PowerPoint slides. So I've CDK deployed this stack already, and you can see the response there. It's deployed successfully. Just by the way, something I've noticed only today, actually, this is the response I'm getting back when I do a CDK deploy. It's essentially telling me that the CDK framework, um, there's a new version out of it, or the current version is, where does it say it? Uh, does it say it here? I'm sidetracking now for a second, but I just thought I'd bring it to your attention. Oh yeah, you can see here that the CDK is at version, sorry, where does it tell me the version? Here, right? CDK, it's kind of unusual actually. The current CDK version is C.1000. Now, I've never seen a library that has a minor version number of something as high as 1,000. Like only about 4 weeks ago, the version was .176, but suddenly it has jumped up to 1,000. So there's obviously something significant going on in the CDK development team themselves. But either way, the CDK has now ramped up to that 1,000. That may slightly impact on us. We'll have to wait and see. I might upgrade my own to that 1,000 just to see has it make any difference. It shouldn't, because there shouldn't be any breaking changes, because it's only a minor change number, not a major. But it has suddenly jumped from 176 version number about 4 weeks ago to suddenly 1,000. So they're obviously doing a lot of development work on the CDK team. But anyway, that's kind of by the way. From the output from my stack is this. When you're using the API Gateway service, it automatically, when you deploy the stack, it automatically outputs the URL of your web API. I mean, if you look at my stack file, I pull this down again. I don't have any explicit output from my stack file, but I'm still getting as output the URL of the web API. So that's it there. And before I switch over to Postman, here's my Lambda function, and all of the endpoints in my web API is targeting the same Lambda function. And it doesn't do anything other than a console log, but it'll be interesting just to look at the structure of the event object that your backend Lambda receives. And other than that, it just sends a response of 200 OK. Right, so if I grab the URL that I have, and if I switch over to Postman, I've got a collection here ready to run with. And I'll set up an environment variable called URL, change my URL to the new one, save that, and let's do a get request. Yeah, let's do that. So this is just a get to the URL slash to-dos. I don't want all of that, sorry. Let's get rid of those for now. Okay, and do I need to do another save? Let's send my request. Okay, we're getting back the success from the Lambda. Let's switch over to CloudWatch. Here's my log stream from the Lambda function, log group, sorry. Here's the log stream. And if we look at so this is the part of the stream linked to the console log. And here's the event object itself. Now there's lots of stuff in there, most of which is not particularly interesting, but if we scroll down to here, it looks like there is a thing called query string parameters here. Now our request didn't have any query string, but if it did, and I'll illustrate it in a moment, then we can get at the query string parameters from the event object. So that's part of this integration that's performed by API Gateway when it receives a HTTP request, and it has to pass that on or proxy it on to a Lambda backend. It takes the query string part of the request and it packs it into the event object for us as a convenience. Similarly for path parameters here, right, of which there are none, again in this case, and the body is empty as well. Okay. Is there anything interesting in there? Let's go back up again. Okay, well, it's kind of confirming here, like that the path was the slash to do path, slash to do's path. The method was a get. Yeah. So, okay, not terribly interesting, I'd have to admit, but let's do a post instead. So if I go to this request, so it's a post request to the slash to do's endpoint. Now I need a body in this case, so I'll just hard coded a body for myself. So this is my request body. And let's see where that is going to appear in my event object, although I've kind of already given you a hint as to where it will be. So if I send that request, again, I'm getting the success response back from the Lambda. But if I go back to my CloudWatch, so sorry, just let's look at the detail of the body. I have a title and a description, okay? So if I go back to my log stream, and it's using the same micro VM instance for my Lambda. As it turns out, it hasn't created a new, it hasn't destroyed the first Lambda micro VM and created a second one. Just by the way, we can tell that. But here's the console log for the second execution of my Lambda. And again, if we scroll down to the very bottom of it, we can see here's the body here, and it's a what the what the API gateway does is it stringifies my my request JSON structure. Like what my HTTP request sent was a raw JSON structure, but the API gateway, as part of the Lambda proxy integration, it stringifies the payload, and that uh, we can see that here. Okay, so you do have to be conscious of that. If you want to process that body, which in many cases you would, if you want to process the body of the or the payload of the request within your Lambda, you first of all have to parse this string to put it back into a form that can be processed by your TypeScript, JavaScript, which would really be just to parse it into a JavaScript object structure. But that's straightforward enough, really. And again, we can see that the path name was slash to dos. In this case, it was a post request. And the final piece, well, we can let me see. Oh yeah, we had another endpoint or a path, sorry, which was a get request with a parameter part to it. So if I just do this, if I bring up this, and if I add on, let's say just 1, 2, 3, 4. So 1, 2, 3, 4, Maria would be a to-do ID. Send that request. And the only thing we would need to know is how do we get at this 1, 2, 3, 4 within our Lambda? And hopefully you already know the answer to that, because if we now look at the log stream for this third invocation, which is sometimes these aren't in order, so it's actually this one here, I think. And if we look for the path parameter, uh, there we go. Okay, so it actually, and you could have more than one parameter in your path, but it looks like what the API gateway does is it puts the path variables into a JSON structure for us, okay, as a convenience. And so we can just extract those within our Lambda if we need to. And we'll see how to do that in this week's lab. So it's straightforward enough kind of stuff really. Once you get 1 or 2 little opportunities to practice it. So that's my CDK code for creating your kind of 101 a web API using the API Gateway service. Uh, so the integration type that we're using is Lambda proxy, and I've kind of already alluded to this, but part of what this Lambda proxy integration type will do is if your request contains some query string parameters, so for example, let's supposing this was query string parameters, then those query string parameters are are um, are transformed are transformed into a nice convenience JSON structure and included in the event object that's made available to your Lambda. And I'll just finally just illustrate that, even though it's fairly simple, really. So if I go back to, let's say here, and if let's supposing add 2 query string parameters, okay, and you can see the query string parameters are appearing here. And if I now send that request and finally look at the log stream for that, so the query string parameters again were, there's a key called contains, All right. There's a key called contains, and it has a value called lab work. And there's a key called completed, and it has a Boolean value called false. That's my um, and clearly, what query string parameters are permissible and what they mean. That would be all part of the Web API design. So I'm just certainly adding these onto my Web API, even though they weren't included in my design, but they should really be part of the design. But how do we see these query string parameters within our Lambda? Finally, let's look at the log stream one more time. This will be a quicker way of doing this than the way I'm doing it. Let's do a refresh. And it should be this one here, hopefully. Yeah, and there we can see the query string parameters in a nice, convenient JSON object that can be accessed now by my Lambda. Although you just notice here, right, that false, really, you have to obviously convert that to a Boolean as well within your Lambda code. Yep. So that's path parameters. I've already kind of explained that really. Um, the only thing I didn't look at, I guess, was if I go to the gateway service itself. And here you can get a list of all your APIs, your web APIs. I've only got one. So this is the web API that I deployed. And if you go into that, it does have some nice kind of visuals representing the design of your web API. And so what it's telling us here is that, look, we've got a to-dos endpoint that supports a get and a post request. Every endpoint supports an options request by default. Within the to-dos, there's an extension, which is my parameter part, that supports a get only. And if we select any one of these, let's select the post, then we're told over here what type of integration, and it looks like it's a Lambda integration, which indeed it is. So the console can be useful to us as well. The console interface can be useful to us as well sometimes. But other than that, it's all fairly predictable, I think. I'll just pause in case there are any questions so far. No? Right. That's all I want to cover on web APIs, but as I've said a number of times, if I go back to the code and let's just look at the code itself. Where are we? Stack file. Yeah, so if I have mentioned to you before that if you mouse over any one of these, so let's say REST API, if we want to get some more detail of the actual documentation on that L2 construct, and in particular, now we know already, right, that all of these L2 constructs, they all take three parameters, okay? They take the scope parameter, which is always this. Second parameter is always an identifier for your construct, which is just an arbitrary string. And the third parameter is what we call the props parameter. And the props parameter is always an object, right? But of course, the properties of that object will vary from L2 construct to L2 construct. And if you ever want to find out, well, what are the different properties for a props object for a particular L2 construct, well, one place you can Google it, of course, but um, you can actually get that information from within your VS Code by simply mousing over the particular construct name, clicking on it, and I don't want to declare that class myself. I want to use the inbuilt one. And so I'm suddenly now inside in a TypeScript declaration file that comes with the CDK library. And here's my REST API class. Uh, and if I drill down a little bit further, if I look at the constructor for it, let's see where there's the constructor. There's the constructor there. And I'm particularly interested in the third argument, the properties argument. And the properties argument, it looks like it's defined in this type. And if I select that, I'm brought to another part of the CDK library's set of type declarations. And I'm now looking at, what am I looking at? I am looking at, did that bring me to the right place? Sorry, just one sec. Just going to go back there now again. All right, let me just do that again. I'll go to here. Where's my constructor? I found constructor the last time. Why am I not seeing it this time? Oh, there we go. And I want to select this. Okay, yeah. So it's an interface this type or an interface data type, and and it does extend another one, so we may have to look at that one. But for now, here are some of the options, the properties of the props object that we pass to our REST API constructor. And can we find cores in there? Maybe not. Generating API keys. And the documentation can be useful sometimes. Just looking for the cores one. Is it there? Doesn't seem to be the cores setting. Maybe that may be defined in the super interface, if I might call it that. This one here. So you sometimes you may need to just poke around these type declarations if you're looking for more detail on the various configuration options, because that's essentially what these are. Um, anyway, you can play with that yourselves if you want in your own time. But it is worthwhile just poking around a little bit, I think. But for now, I'm gonna park API Gateway, and I'm gonna move on to another service called Cognito. And we nearly always talk about Cognito when we talk about API Gateway, although Cognito can exist independently of API Gateway. So what is this Cognito service all about? And I'm putting it under kind of this set of serverless state management services that are available on the AWS platform. And in particular, it's the state here kind of relates to your user accounts. You know, most applications, certainly most web APIs, would have a user accounts data associated with them. Now we can store that data inside in your standard DynamoDB tables, but the Cognito service is specially designed for such state. Right. So if we want to give users some sort of an identity to allow them to use our web API, although it doesn't have to be just web APIs, then that's where Cognito comes in. From a kind of infrastructure point of view, there are two types of Cognito uh, infrastructures that we might want to create, either a user pool or an identity pool. Now, we will be only interested in creating Cognito user pools. And essentially, you could think of a Cognito user pool as a database of with your users' credentials and other maybe profile related information for each of your users. Uh, but also, if you want to provide your kind of standard sign up, sign in, uh, sign out type functionality, then the Cognito user pool infrastructure has that kind of built into it as a convenience. And it is also, oh yeah, so I'm just saying here it's got very tight integration, not just with API Gateway, but also with application load balancers, if that was part of your infrastructure. The So this is very much in the kind of log in, log out kind of authentication mode. Sometimes you may want to give your users access to particular resources. Now, the simplest example would be an S3 bucket, and you want to give users the ability to upload files to an S3 bucket or uh, delete files from an S3 bucket. Now, in that case, user pools don't really deal with that. In that case, we would need a Cognito identity pool. And you can use identity pools with user pools. But if access to particular resources, direct access to particular resources, if that's something that you want to provide to your users, then you need to look at the whole area of Cognito identity pools. As I said, we won't be concerning ourselves with that in this module. People often kind of are curious about, well, what's the difference between Cognito and IAM? Because we know that in the IAM service, the identity and access management service, we have the notion of users as well, and it's about giving users access to resources, which it sounds very much like Cognito identity pools, and in fact, it kind of is. They overlap. But as a kind of a very general rule, if you're talking about high numbers of users, like in the hundreds, then creating 100 plus IAM users, unless you can automate it in some way, is not convenient, obviously. Whereas incognito, we typically are dealing with user numbers in the three figures. So if it's large user base, and if it's about giving users access to your applications, be they mobile users or web-based users, then don't think about using IAM. Think about using Cognito instead. Whereas if you've only got a small number of users, like a handful of users, that you want to give them certain privileges, then maybe the IAM route is the best way to go for that. So we're going to focus in though on Cognito user pools. Um, okay, so you can kind of think of a Cognito user pool as what I'm calling it here, a serverless user database. Okay, it's not really, doesn't really use databases internally, but it's a nice, convenient way of thinking about it. And in particular, if user database for your web or mobile apps. All of this stuff is built in, as I said, your standard kind of log in, log out, but also things like resetting passwords is a very easy thing to enable. Providing email verification on registration, that's built into Cognito user pools, multi-factor authentication, federated identity if you actually want to allow users to use their Google credentials or their Facebook credentials, you can configure a Cognito user pool to allow that. Blocking users, all this kind of nice, typical features that you'd like to have available for in relation to your user management. That's kind of all built into Cognito user pools. And the whole JWT, JSON Web Tokens, which is going to be important to us. That's a part of the Cognito user pool as well. We'll see that in a while. This is kind of the high level, very high level of the flow, if you like, when we're using Cognito in conjunction with API Gateway. So the API Gateway here is representing the interface to our backend functionality. That's what we've been talking about up to now. But in terms of just the user management side of things, uh, Cognito and API Gateway uh, play very well with one another. And so your typical kind of scenario is your user, first of all, authenticates with Cognito. They provide their username and password. Cognito verifies that they are a valid user by looking up the relevant user pool. Then Cognito returns a JSON Web Token. And again, so many people are familiar with JSON Web Tokens from somewhere else in your studies. A JSON Web Token is essentially a means of identifying the user for a particular session. And that JSON Web Token then is returned back to the client. And for all communication with your API gateway for the purpose of accessing your backend functionality, those requests will include the token that has been issued by Cognito. And your gateway will communicate with Cognito, asking it essentially, is this token a valid token? Did you generate this token? Um, and it'll either respond yay or nay. And that then will determine whether it will accept the request and forward it on to the back end. That's a very high level view. We'll drop down one level though in a slide or two. So from a CDK point of view, how do I create a Cognito user pool? Surprise, surprise. It's another L2 construct. And, again, it has lots of configuration options. I'm just showing you a small subset of them here. The sign-in aliases. So this is essentially saying that email addresses will uniquely identify users just as well as a username. So when a user registers, they'll provide a username and an email address. The second option self sign-in, that is set to true means that users can register themselves uh, for access to your application. And the removal policy, that's a bit like the removal policy that we had with DynamoDB. So by setting the removal policy uh, to destroy means that when we CDK destroy the stack, we want to CDK the user pool as well. And again, that would be only something that you might do during development. You wouldn't necessarily do it in production. You'd want to hold on to your user base, perhaps. Now, as well, when you create a user pool, you also have to create what's called a client for that pool. And that client then is actually going to be used by any of your lambdas that needs to talk to the Cognito service. And that will be an issue for a number of our lambdas. We want to write lambdas that talk to Cognito, and the way they tell Cognito which particular user pool should Cognito reference for the purposes of the communication, then you specify that by specifying the client associated with the user pool. So that's just a piece of the lower level kind of infrastructure that we need to create. And okay, user password. The authentication flow is your kind of standard password type flow. Now you can actually um, define your own authentication flow as well, a custom authentication flow, and that would be something that would be relevant in some cases. But we're using the kind of built-in, if you like, user password authentication flow for convenience for ourselves. Now, when you CDK deploy this, then if you go to the Cognito service, then you will find that there is a user pool which has a auto-generated identifier comprised of the stack name, the name that you specified up here, and some sort of hash value. That's the complete identifier for your user pool. We'll look at that in a moment. Now, what I'm showing you here is your more typical infrastructure when we're using Cognito in conjunction with an API, a web API. So the way you kind of break this down is down here, we have a web API, which is the interface to our actual application's backend functionality. So let's just, for simplicity's sake, this is the bank of lambdas that provide the functionality associated with our application. And here's the front-end gateway for it. But separately, you would also have a web API which deals with all authentication related requests. Now we could combine these together, in some cases they are, but it's probably better from a separation of concerns kind of perspective. A lot of organizations would have separate web APIs, one that deals exclusively with authentication related requests, the other one which deals with requests targeting the actual application itself. And the flow then from the client's perspective is clearly you first of all need to log in. So you provide your user credentials, your username and password. That's a standard kind of HTTP request to this web API. It will proxy that on to a Lambda. So there's going to be a number of Lambdas up here. And these lambdas, which we write, but they're pretty much boilerplate. These lambdas deal with, user registration requests, user login requests, user logout requests, and these lambdas need to talk to the Cognito service. And the Cognito service then manages the actual user pool, which Maria is over here. But for a standard kind of login request, then this gateway proxies the request onto the relevant Lambda. The Lambda then will talk to Cognito. Ultimately, if Cognito is happy with the username and password combination. It will generate a JWT token, return it back to the Lambda to the gateway, and the gateway back to the user. The user now has a session token, if you like, based on the JWT standard, and that token then is included with all requests to this web API. Now, what this web API needs to do is it needs to validate or verify, sorry, the JWT token. And so there is a Lambda function again, which, well, there are built-in Lambdas, or we can customize our own Lambda. We will actually have a custom Lambda. And so what this custom Lambda does is it actually receives the full request that came in here. It receives that in its event object, and that request will include the JWT token. And I should really have a connection from here to here, because this Lambda essentially is going to ask the Cognito service to verify that the token is a valid token. Okay. Uh, and it will either respond positively or negatively. And then this Lambda will actually generate a dynamic IAM policy. And the purpose of the policy will either be to allow or deny the API, this web API, to access the backend or not. Okay. So the last part of that jigsaw is that this Lambda, it generates an IAM policy that either denies or allows essentially this um, web API to process the original request that came in or not. So this Lambda here and the Lambdas up here are really what we're interested in. We're not really interested in the Lambdas over here because we've seen all of that kind of stuff already in earlier weeks. So from an infrastructure point of view, we need to create a Cognito user pool, a Cognito client. We need to create two web APIs, but these are just standard web APIs, you know. Um, and we need to look at these lambdas as well. So this is kind of a visual representation of our two web APIs on the left. And we kind of conventionally refer to them as the top one as being the auth API and the bottom one as being the app or application API. So my auth API, I've just kind of decided, look, um, these are the endpoints that are available on my auth API. And so there is one called um, there's a sign up. Where's sign up? There's a sign up endpoint. There's a sign out. There's a sign in, and so on. Okay, so there's a couple of authentication related endpoints on this API. And just, we're not really interested, but on the application API, I just have two endpoints, a protected one and a public one. And I'm just using those as the actual endpoint paths as well. And clearly the protected one is can only be accessed if the user includes a valid JWT token, whereas this one can be accessed by anybody. So there's no need to validate the token for the second one. And then down here, all I'm showing you is that, look, here are all of the lambdas now that make up my skeleton application. But most of the lambdas are the lambdas that are at the back end of this web API here. Now, I should have CDK deployed it really. Let's quickly do that. It's going to take a little while now, so I'll just let it roll away. And uh, while it's deploying, if we look at you can see my lib folder here now. I've actually got a couple of files. Now, each of these is not a stack. What I decided to do was, so let's look at the one that actually does have stack in its name. So let's just click in on that. And what am I doing here? I am creating a user pool, which we've already seen. I'm creating a client for that user pool. User pool, sorry, not here. I'm creating a client for it. Now, because there's quite a lot of infrastructure associated with this stack, I could have put everything into this one file, but what you can do is you can take logical units of the stack and put them into a separate class. However, that other class is not a stack file. It's not a stack class, sorry. It's essentially a custom L2 construct of our own. We could have done this for any of our earlier applications now, but um, I'm illustrating it here. So in these two files here, if we just go into, let's say, this one. Now, the first thing to notice is that, okay, this is a class, but it's not extending the stack class, it's extending the construct class. So that tells me straight away that this class, which I've called API, auth API, is an example of a custom L2 construct that I've created for my particular application. And this L2 construct, it's going to take care of, creating this web API and its backend, or if you like, create all of this stuff here. Let me just erase that because it's getting a bit messy. Yeah, it's going to create this stuff here. The Cognito user pool, I created that directly in the stack file. This is an L2 construct that I'm going to have, a custom L2 construct. And equally, all of this here, all of this part of my application, I've written an L2 custom L2 construct for that. Okay. Um, so sorry, go back again. But in the stack file is actually, as I said, it's just creating this stuff here. But the user pool and the user pool client, we do need to pass those into these L2 constructs because it uses them. Yeah. So we need to pass them in as parameters, really. And let's see what else now. So my L2 construct, how do I pick it up from? If I look at the constructor here, here's the constructor from my L2 construct. And again, it has a scope property, as all L2 constructs do. It has an ID property, and finally, it has a props property. But the props property is really, because it's my L2 construct, it's up to me to define what is the structure of the props property for this custom L2 construct. And that's what I'm doing up here. I'm defining a type and I'm saying, look, this props is of that type. And so you can see that it contains two arguments. Um, two arguments, both strings, but This string is the user pool ID, and this string is the user client ID. Okay, and I'm just holding on to those locally here. And then within the body of this L2 construct, the rest should be familiar enough to us in the sense that, look, here I'm creating a REST API. So this is the auth API, web API. That's the top one in my picture that I have from the slides. And I have an auth endpoint. I've just arbitrarily decided that all of the endpoints for my auth API should begin with /auth slash something. Yeah. So that's all I'm doing there. Now, because all of the endpoints for this auth API, they're all quite similar, then again, for no particular reason, what I decided to do was to create where is it? Yeah, create a private method for this custom L2 construct. And this private method, it creates a lambda and it creates an endpoint to my web API. Yeah, like you can see here, like it's creating a lambda instance based on some arguments that are parameters that are passed into my private function, and it creates an endpoint. Where's the endpoint here? Creates a resource, sorry, it creates a resource, creates a lambda, and it specifies what method are associated with that endpoint. So that's what my private method does, which begins, sorry, a bit clumsy at this now. It begins here. And all I'm doing up here then is I'm calling that private method a number of times. And I'm calling it essentially to create the slash sign up, slash sign in, slash sign out, those various endpoints. So you can look at the detail of that yourself later on, but there's nothing really new in there going on there other than the fact that I'm packaging it as a custom L2 construct and the fact that I need to pass in my user pool ID and my user client ID, which have been created here. Yeah, I need to pass those in. And you can see what I'm doing here is I'm just creating an instance of my custom L2 construct, attaching it to the current stack, giving it an identifier, which is arbitrary, and passing in my props object to it. And similarly, I've created an L2 construct for the app API, and that's taken care of in this file here. Sorry, in this one here. And you can look at that yourselves in your own time. In fact, the second of the two labs for this week essentially gets you to set up this entire stack. So my stack has deployed successfully, and this stack has two web APIs, which is why I've got two URL here. So again, if I set up a Postman, how am I doing on time? Okay, I've set up a Postman collection for this application. So if I just take this URL and just be careful you get them in the right order. So this is the app API. Nito Postman collection. And I've got the app API URL. And also the auth API. I do have a third variable here, but I'll just ignore that for a while. Save that. And I want to exercise the auth API first for the purpose of registering a user, signing in, and then we'll see how that works. Let's see, where am I now? Okay, let's just do a registration first. And the registration is going to be a post request. Sorry, now if I go back to here again, registration is going to be a post request um, to this. Where is it? Yeah, to this endpoint /auth/sign up, and it only supports a post request, and the body has to include a username, a password, and an email. And again, okay, let's just take it as read. That's what it requires. So if I go to sign up, so it's a post request to the endpoint that I mentioned, and the body is, as I'm showing you here. So my user's username is user A, password is that, and their email address is that. Now, when I configured my Cognito user pool, if I go back to the slides, where did I configure it? Here, when I configured it, I said, first of all, users can sign up themselves, self sign up. So that's why I've got the endpoint that we're just about to look at. And I also, in the client, I said that the authentication flow should follow the built-in user password authentication flow. And that's what dictates, and as well up here, sorry, I said that, where did I say it? Here, right? I said that email address should also be included in a sign up or in a registration, and that would be an alias for a user's username. So a user provides a username, but they also must provide an email address. And we're following the user password authentication flow. So all of that kind of collectively, that dictates what I'm including in the body of my sign up request here. Yeah. So let's click send. And if we look down here, it looks like I got a 200 response. So that was successful. Now, because I'm using the built-in user password authentication flow, the way it works is that when the user signs up, and given that they have provided an email address, then the Cognito service will send an email to the provided email address, and it will include in that email a sign up code, and the user must then confirm that sign up request by using that code. Now, in my case, that sign up confirmation is a separate endpoint in my auth API. Because if we go back to the slides, if we go back to here, there is you can see here an auth confirm endpoint that's specifically for this part of the registration process. So if I go to the email address that I provided, I need to bring up my Gmail, and did I receive it? Should have received it. There it is there. And here's the code that I was provided with. So I now need to use that code in my confirmation request. And if I go back to Postman and I select this request here, it's a post request to /auth/confirm. It needs a body. The body, again, is dictated by Cognito. The body needs to include the username that you provided when you registered. And I now need to here replace this with the actual code that I got. Go back to my Gmail and I'll just copy the code. Now, just before I send that request, I'm actually going to flick over to the Cognito service, which we haven't looked at so far, but that's okay. And let's select user pools. And here's the user pool that was created for me. And if I select, what do I want to select? I'm going to get rid of that anyway. What do I want to do? Am I in the right place? Oh yeah, if I select users here on the left, and you can see here's my user A that I registered, but you can see that their status is unconfirmed, which means they haven't confirmed their registration. Now, that's what I'm about to do back in Postman. I'm about to confirm my registration, so I'm going to send this post request. And I'm getting a message back that looks good. If I go back to my user pool and I do refresh, you can now see that the user's status is confirmed. Now, okay, what's actually going on here now? Who's doing all this work for me? Who's talking to Cognito? So if I go back to my slides, okay, I have my auth API here, and I've shown you just excerpts from the stack that created this. But when I deployed the stack, what that actually did was, if I maybe go to here, it created this web API and it also instantiated a whole bunch of lambdas, okay, which are lambdas that I wrote. I go into the lambdas part. Here's a whole bunch of lambdas, and you can tell from the names that it looks like, if I pull this over a little bit, it looks like this is the lambda that may have executed when I did my registration. This is the lambda that was executed when I confirmed my registration. Now that's all I've done so far. So let's look at those two lambdas, how the lambdas were triggered, which simply by the lambdas were just triggered because there was HTTP requests sent to this web API, the auth API, and the auth API was configured to proxy the request onto the relevant lambdas. And so let's look at the lambda that was triggered when I registered a user. So if I go forward in my slides, that's this lambda here. And there's nothing actually particularly unusual going on here. I'm creating in this lambda, I'm creating a Cognito client. Now, this is a sorry, this is an SDK client. Now, this is not the Cognito user pool client. Fortunately, there are two clients active here now. So this is the Cognito service client. Let's call it that maybe instead, which allows my Lambda to talk to the Cognito service. And here's the actual handler itself. Now, what's really nice about the SDKs that have been provided by AWS for the various services. Like so far, we've only looked at the SDK for the DynamoDB service. And you'll remember that the programming model was along the lines of for DynamoDB, you create a command object. So in the case of DynamoDB, it was, let's say, a put command when you wanted to write a new item to a table, a get command, a query command. So it was all modeled around this command pattern. Now, the SDK for the Cognito service, it follows that same style. The commands are obviously different types of commands, but it's the same idea. And in fact, if you looked at various other AWS services like SQS and SNS, and if you want to write Lambda code to talk to the various services, then the programming model is actually very similar across all of the services. And that was obviously a conscious kind of design decision that the AWS people made to make life easier for us as developers, I guess. Now, in the case of Cognito, uh, what I'm doing, for example, is I'm creating an instance of a sign up command. Uh, and here all I'm doing is I'm extracting the username, email, and password from the HTTP request. I'm extracting it from the body. What am I doing up here? Sorry. Yeah, from the event body. We saw the event body earlier on when we were looking at the to-dos application. So the event body contains the body of the payload of the HTTP request. So we're extracting these parts of the payload, and then we're using them in the construction of my sign up command object. And then I send that command object to the Cognito service essentially. And that's kind of similar to sending a request to the DynamoDB service from previous weeks. So as I said, it's a similar kind of programming model. And what I get back as a result, and the result presumably I probably should have some check of the result there. I'm assuming that the result is successful. The reasons it might not be successful is, I don't know if I mentioned this, well, I didn't in the slides, like there is some standard validation done on the password that you provide. You know, there are certain minimum requirements that Cognito imposes on passwords, like have to be of a certain length, have to contain a mixture of upper and lowercase and non-alpha numeric characters and all that kind of stuff. So it has a small set of predefined constraints on the password structure. Of course, you can augment that, and you would specify that in your CDK stack as part of the user pool configuration. No, I didn't do that, so I'm accepting the defaults. But that's one reason why this when I send it, where do I send it? Uh, yeah, when I send the command here to the Cognito service, the only reason it might throw an exception, well, one of the reasons might be the password has actually failed the basic validation tests. So I should really be checking that here, I suppose. It will throw the exception anyway back to my uh, to my to my postman, and you can play with that yourselves. So that anyway, this is the Lambda that deals with the registration request. Uh, okay, I've just got a couple of minutes left, if that's okay. What I did then was I sent a request to the confirmation endpoint. You saw me doing that. So that equally, if I go back to here, that confirmation request would have been directed at my auth API, and it would have proxied it onto the Lambda that deals with that deals with confirmation requests. So what does that Lambda look like? And surprise, surprise, it's actually very similar to the sign up Lambda. As in, do I actually show it? Yeah, here's the confirmation Lambda, same flow, right? Create an instance of the Cognito service as part of my Lambda initialization. I'm extracting the username and the code uh, from the body of the event. In this case, I'm creating what am I creating? I am creating a confirm sign up command, configuring it. I'm always in the case here, you can see that I'm passing it, or sorry, I'm configuring the command with the client ID. This is the user pool client ID. And if I go back to the sign up, I also need to provide the user pool client ID. We always need to do that. We always need to tell the Cognito service which user pool should it be referencing to when dealing with these requests that I'm sending it. So jumping around a little bit now, but here's my confirmation Lambda. And again, create the command object, send the command object to the Cognito service. And again, I'm not checking that there are any problems. The obvious problem would be that the code is invalid. And I would get an exception thrown back to my Postman client in that case. And it has to deal with it. Otherwise, I'm sending back very successful response. Let me just try one thing just to show you the error kind of scenario. If I try and register a second user, so sign up, post, and let's say I call this user B. And I'll give terrible password. I'll call the password, say password. That's W. Hopefully it should reject that. And I'll just give a fake email. Now, the message that I'm getting back here will relate to the password, not satisfying certain criteria. So that side of it works. And anyway, that is something that your client would have to deal with anyway. So there's no point in having any exception handling code in my Lambda. It can't deal with that. Okay. I was hoping to finish these slides today, but doesn't look like it. So I may as well stop here. But from a labs point of view, where are my labs? You can certainly work your way through this lab, and just remind myself what this lab is. I think it's doing the movies API again, sort of stuff. Yeah, you can certainly work your way through all of that, and you could start the Cognito lab. You could really try and work your way through all of it if you want to, but you certainly could do the earlier parts of it, and we'll finish off the login. So I have registered a user and I've confirmed that user. The login is straightforward as well, but what you get back from a login request is your JWT token. And the only kind of slightly clumsy part is knowing how to use the JWT token when you want to send requests to the actual app API. I've decided that, or if I go back to here, so I have my JWT token now after logging in, and I need to send requests down to this API, but I need to include the token, and I've arbitrarily decided to include the token as a cookie. So this Lambda here has to extract the JWT token from the cookies that were included in the original request and then pass the token to Cognito for verification. So this Lambda here is quite involved, but again, you can almost take it as boilerplate code that you can reuse yourselves, and you will be using Cognito in the assignment. So next week I will um, give you the details on the first assignment. I need to finish this set of slides and then give you a briefing on the assignment, and then that will be my part of the module kind of completed. I may come back again in week 12, depending on how much progress Frank makes. Okay, I've talked too much, so I'm going to leave it at that for today, and I will talk to you on Thursday. And again, I'll wait just in case there are any questions from anybody before I wrap up. No, okay, I will touch base with you on Thursday. Thanks, bye bye.